this is Chen Hui Min. I'm from Geotechnic 2, Section 6 and Group 4. So here are my group mates, Chong Hui Ling, Oi Wei Wen, Palisli and Vasuntra. The title of our project is Case Study on Internal Erosion of Cohesive Soil and Cohesionless Soil. First of all, internal erosion is used to describe the separation of fine particles from the main soil structure because of the mechanical or chemical action of fluid flow. It is a complex phenomenon which can bring some major problems to the stability of levees, dikes, and embankment dam. It can erode the strength and stability of the granular skeletons of coastal waterfront structures and their foundations, comprising their strength and stability. There are three stages of internal erosion, which is initiation, continuation, and progression. There are some types of erosion, such as suffusion, backward erosion, concentrated leakage erosion, and piping erosion processes. These are the examples for erosion. For suffusion, seepage flow undermines the small particles through voids between the larger particles and leave the soil skeleton behind. For piping erosion, the soil particles are gradually eroded and transferred along a fluid flow route. For backward erosion, outward seepage separates particles from the downstream surface. Since the internal erosion can lead to many failures of earth structures, such as failure of embankment dams, failure of dikes, and accident. Thus, the study of soil erodibility is critical and important for geological land development and soil conservation. So, in this project, we aim to look into the effect of internal erosion on cohesion soil and cohesionless soil, and also look for the solution to overcome this problem.
Hi, I'm Palisli and I'm going to present on case study for cohesive soils, and this is the first case study that is laboratory parametric investigation, and on this investigation the researcher used whole erosion tests to determine the erodibility of cohesive soils that may be prone to internal erosions and estimating the rate of concentrated lake erosions. And this study is concentrated on three important factors, that is dry density, moisture content, and clay content. And the results show that critical shear stress is affected by those parameters. And it is well to take into account how the moisture content and dry density and percentage of clay content is affect the resistance of soil against the internal erosions when designing earthfield structures or doing risk analysis on the internal erosions. So the second case study is about specific transient device to study the internal erosions, and the good tests show that the hydraulic gradient at internal erosions depends on clay content and filter process. If the clay content is low, the sand particle erosion is added and the polyskeleton is broken down. And the erosion begins when the soil is fractured or weakly compacted, allowing large gaps between clay particles. And if the sample cannot be measured by this device, adding a mass balance to the measuring chain will help. And difference sand or clay ratio and filter opening size can be used to expand this research. And the purpose is using this device to test confining pressure on internal erosion dynamics. Thank you.
Good day to Doctor. My name is Wen. Right now I'm going to present case study on cohesional soil. The first topic of the case study on cohesional soil is influence of soil and hydraulic condition on the processes of internal erosion, cavity formation, and collapse behind coastal structure. The findings and conclusions are The formation of cavities and the timing and scale of their collapse are influenced by differences in suction. The process of internal erosion is influenced by the type of hydrodynamics. Cavity collapse occurs when suction drops, regardless of the type of water table fluctuation. The results suggest that it is possible to predict the collapse of the cavity based on the observed surface displacement of the artificial beach. Filters with a high uniformity factor have a high deterrent effect on the internal erosion. The second topic of the case study is strength reduction of cohesional soil due to internal erosion induced by one-dimensional upward seepage flow. The findings and conclusions are: the relationship between mean hydraulic gradient and flow rate is essentially linear when internal erosion occurs before. After erosion has begun, the slope of the relationship is no longer linear, suggesting that the hydraulic conductivity of the soil increases sharply as internal erosion proceeds. The lower the fine content, the greater the hydraulic gradient required to cause internal erosion. An increase in the applied hydraulic gradient results in an increase in the loss of fine. Internal erosion leads to a reduction in cone tip resistance, the extent of which may be related to the imposed hydraulic gradient. A higher imposed hydraulic gradient indicates a greater loss of fine particles and will lead to a further reduction in cone resistance. Within a certain range of hydraulic gradients, internal erosion leads to a decrease in the shear angle of the soil specimen. The third topic of the case study is internal erosion failure of uniform sands under confinement and constricted seepage exit. The findings and the conclusion are: the experimental results show that the confinement pressure, particle size, and the size of the opening at the seepage outlet have an effect on the critical velocity where the discharge rate at which internal erosion failure occurs. The higher the confinement pressure, the higher the critical velocity for a given particle size and size of the seepage outlet. The larger the particle size, the higher the critical velocity and vice versa for a given seepage outlet size and confining pressure. The larger the seepage outlet opening, the lower the critical velocity for a given particle size and confining pressure. In the proposed hydromechanical model, the critical velocity is influenced by the particle size, seepage opening size, and confining pressure.
Hi, I'm Vasundhara Bhaskaran, CF200191. As you can see here, this is a ground improvement, is the modification of existing site foundation soils to provide better performance under design and operating load conditions. You can see there are several ground improvement techniques. The first one will be increase in soil load bearing capacity by making it denser. Second, reduce the soil settlement. Third, reduce the liquefaction during earthquake occur. And fourth, reduce a large amount of pore water pressure. Fifth, avoid liquefaction. And fifth is avoid shrinkage and expansion. Sixth, no ground lowering or excavation. And next one will be design a drainage system. And the last one to improve the pH value of the soil. See the ground modification techniques, which is there is two parts, which is physical modification and chemical modification. Physical modification, mixing the adhesive with surface layers or soil columns. And the second adhesive includes natural soils from industrial byproducts or waste. And the last one, stabilizing soil by thermal modification method. And next, when we talk about the chemical modification, the transformation of soil index properties by adding cement, fly ash, and lime. And the next will be alters the physical and chemical properties of the soil, including the cementation of soil particles. Let's talk about physical modification techniques. You can see in this slide, it is vibro floating, which is VF process used for dense soil formations which do not contain any optimum relative densities. And next, it is also mainly granular soils are naturally deposited or backfilled. And the next one will be soil particles rearrange and adopt a denser packing, which under the influence of the horizontal vibration. This will be the soil nailing. The basic concept of soil nailing consists of reinforcing the ground with closely spaced passive inclusions to form in situ soil and limit its displacements. The basic design consists of transferring the resisting tensile forces created in the inclusions to the ground through the friction forces mobilized at the interventional resistance.
Selamat sejahtera total. I am Chong Hui Ling and my metric number is AF200156. Now I will continue to present the application. The vibro displacement is an extension of vibro flotation. The stone columns is used to densify the soil layer in a specific area where soil particles are more cohesive and will not backfill the ground during the vibration. The aggregate is compact in the hole in the form of column by rotating the probes, increase the strength, and stabilize the soil problems. The deep compression is fast and economical. And there are two types of verbal replacement. First one is wet feed, or we call top feed. The second is dry feed or bottom feed.
The wet feed, or we call top feed, is the penetration in soil is done through and soil is examined. It compact filling of the aggregates and fill and consolidate to complete the columns. And this is the steps for top feed fiber reduction. The dry feed, or we call bottom feed, is the soil is penetrated and examined. The aggregate installed done through separate duct along the micro probe. The consolidation of granular soil is performed to complete the column. And this is the picture for step 4 bottom feed fiber reduction.
And next, we will continue with the chemical modification techniques. And the first chemical modification technique is addition of the sulfates. The iron and ammonium sulfates in organic mixtures are used to reduce the pH of alkalinity to acidic. The best way to lower the pH of alkaline soil is used to the organic matter that can be added as manures, compost, and green manure. Organic matter generally buffer plants for acidity, and the gypsum, which is the calcium sulfate, does not change the pH of the soil, but soil improves the aeration and reduces the compression. The second is the desalinization. Drainage is the primary method of controlling soil salinity. The system should have proper irrigation system to keep water flowing continuously. The salt concentration in normal soil is 5% to the 10% higher than the irrigation water, which means that the salt output matches the sand input and the sand does not accumulate. And in saline soils, the concentration of drainage soils is much higher than the irrigated soils, which means that the salt export will higher than the salt input. And for the last chemical modification, the next is the additional gypsum. Clay to sweat exclusively when the wet due to the higher solidity. The clay particles are separate, which is the dispersed, and this aggregate is weakened in the soil, which causes the structure correct and closing of the soil pool. Gypsum, which is a limb compound, which called the calcium carbonate, is a compound that contains calcium. Hence, is conducive to reduce the effect of the solidity.
In conclusion, our aim in this project are achieved. We had looked into the effect of internal erosion on cohesion and cohesionless soil. And also we had looked for the solutions to overcome the internal erosion. Several experiments and tests are studied to determine the effect of internal erosion. For horizontal seepage-induced subfusion experiments, its focus in subfusion. For experimental bench, internal erosion can change the hydraulic qualities of soil and mechanical behavior. For sand filtration test and prototype scale experiment is to identify the appropriate particle size distribution for the filter design. For one-dimensional upward seepage test and cone infiltration test are to study the reduced strength of cohesionless soil due to internal erosion. Lastly, a hydromechanical model is to help describe the onset of internal erosion by incorporating the fluid resistance of sand particles caused by seepage and the more column failure criterion. Throughout this project, I get to know the internal erosion occur only when the size of the fine particles is smaller than the size of voids of coarse particles, and when the hydraulic gradient is large enough to allow the fine soil particles to pass through the voids between the coarse particles. And there are some ground modification techniques to modify the ground properties. And I get to know filters is important in preventing erosion and allowing drainage of seepage water. So that's all for our group project. Thank you so much, and we hope you enjoy our video.